also control the flow to this. Okay? And this flow control is based on the spool opening and closing amount. Okay? The spool opening and closing in without any control is full open or full close. Okay? Here it is intermediate opening is possible, which will allow, right, a servo. Okay. So first I will show you the mechanical aspect. How exactly the spool closing and opening is possible in a mechanical way, and then we will see the electrical approach of controlling this directional control valve, and that is the basis for mechatronic system for the hydraulic, based on hydraulic actuators. Okay? And the components over here are very much associated with the control unit. The components over here are associated with the hydraulic components, directional control valve, but it need not be directional control valve. I can even control the flow to this actuator by three means. One is by controlling the motor drive itself. Which motor? The motor to drive we know that we use motor goes through right? This is in general. Of course, there will be many other components. So, motor speed I can control by sending this signal to the motor control unit, and still I can control the motor speed. I can stop the motor, start the motor. Accordingly, the fluid flow will be controlled over here, because the speed of motor will decide the amount of pumping fluid which is rising, right? Quantity. So the one is the motor control, which is generally very efficient. However, the motor is much heavier, and it is not very small motor to just operate it so quickly. It has its own inertia and its own various dynamics associated with it, and hence although motor control is efficient, it is not desirable when we want to operate very precisely of the order of micrometers or few tens of or hundreds of nanometer positioning control. Motor control is not very easy. Okay, so the second approach is pump control. I can also control this pump output, right? But not by special gear pump, but there are different other pump configurations which can allow fluid flow with a certain quantity of amount to be driven, etc. So I will need some form of mechanical systems to control the pump system. So that is the pump control. And the third approach is DC valve control. Okay, directional control valve, which is not so efficient. Why? Because motor will keep pumping, motor will keep rotating. Even if the DC valve is in operation, motor will keep rotating, pump will keep pumping. Whatever the high pressure fluid is there will return back to the tank through the pressure. So it's not an efficient process. However, it is very precise because very easy to control this directional control. Now, what are the signals which can help us to control this? One is the position. Right? It can be speed. I want to control the speed, or it can be force or pressure build up. Okay, if the force builds up over here, the machine should stop or position itself somewhere indirectly. So I can use either of the three signals, position or velocity or force or pressure, to control either of the three. Generally we prefer DC valve control to, right, to achieve desired output over here. Is it okay? So of course, to pick up the position or velocity or force, we use sensors, transducers, depending upon our requirements, pick up that signal and control the DC valve over here. Okay, so we will focus in the next class about this servo control valve mechanism, how it looks like, how it is being operated, how it is being used in the practice to control either of these parameters. Okay, right, output parameters. Is it okay? Right. So we will go to the next class on Thursday.